Okay, so rational functions is our next topic. When we're doing rational functions, there's going to be two main ideas. We're going to see what's going on with x. We're going to see what's going on with y. Okay, so a rational function is a fraction. So the first thing we're going to do with talking about fractions is a non-permissible value, and sometimes in my work you might see me call this an NPV, non-permitted value. So everybody should know this. What am I not allowed to do in a fraction? What is not allowed in a fraction? No zero denominator. I can't divide by zero. Okay, so here, what is the value for x that would cause this problem? If x was 2. What about in this next one? If x was 5? I'm going to skip this one and come back to it. Before I tell you this one, what kind of work can you do to this expression on the bottom? Difference of squares? Then that helps me see what are the non-permitted values. The non-permitted value is a -3 or a +3. Okay, and what would you do for this work before you go into looking for the x? You should simple trinomial it. Okay, so going back to this one. So I'm trying to figure out what value I can't have for x. What would the value for x squared have to be? Blah plus 1 makes 0. What would you say? -1. So what's the solution to this? What do you square to get -1? You can't, right? So guess what? There are no x values that will be a problem, right? No matter what I square plus 1, I will never ever make a 0 out of that. Okay, so we learned this already, that when you have a divide by 0, what does it create on a graph? We just did this with reciprocals. It makes a vertical asymptote. So if I had this, it would make an asymptote, a vertical asymptote. So on my papers, you might see me do this. VA, I'm just trying to shortcut. This is a vertical asymptote. Unless ... There's a special case. Unless this happens, it will make a hole in the graph instead of an asymptote. Okay? The wording in the question. The wording in the question is going to be a point of discontinuity. That's the fancy word to say a hole in the graph. Okay, is it called a point of discontinuity? So on some of my paper, you might see me write POV. So that's what I'm expressing. It's a hole in the graph, a point of discontinuity. Okay, so that's the rule. You look at the bottom, you worry about how it could be 0. You decide where's the vertical asymptote, where are the holes, if any, or maybe there might not be a problem on the bottom. Okay, those are your 3 scenarios. Okay, now let's talk about y stuff. So to understand the y stuff, you have to understand what does a degree mean. So when I look at this equation here, what's the degree of this equation? So think about who's the boss in this equation. Who is the boss? This one's the boss, right? Okay, so what's the degree? 3, because that's the highest exponent. And the leading coefficient is 2, because it's 2x cubed. Okay, so here's the rules. You look at the degree. This one has a higher degree on the top. So think about math. What happens when the number on the top just gets bigger and bigger? Your number just gets bigger and bigger. So if your number gets bigger and bigger, there's no restrictions to it. What do you see about the degrees on this example? They are the same, right? They both are just an x and an x. This is going to create a horizontal asymptote, y equals and then you're going to have to divide the coefficients. So on this example, that would have had a horizontal asymptote at y equals 2. Coefficient. This word? Coefficients. Divide the coefficients together. Okay, last. What's going on with the degrees in the fraction on this one? It's higher on the bottom, right? Okay, I'm going to show you numbers that get bigger on the bottom. So 1/10, 1/100th, 1/1000. What's happening as a number sense? It's getting smaller and smaller and smaller, which means what value is it technically getting closer to? 0. So that's the rule. There. Now you know how to graph all rational functions knowing these rules. Okay? That's it for the outcome. So let's practice this. Okay, so number 1, the first thing I'm going to do is factor the bottom. So x plus 3, x plus 5. So what's X values are not allowed to exist. So what are the non-permitted values for X? -3, -5. But wait, that happens. So what do I know? These non-permitted values, this -3 will be a vertical asymptote. And the -5 canceled, so there's going to be a hole at -5 comma something. We'll figure it out later. Okay, does that make sense with what we learned on the page? Okay, now what's going on with the degrees in this equation? Top, bottom, same, different, what? There's more X on the bottom. So what is the rule? It's going to get closer to 0. Okay, so I'm going to draw these couple things that I know. So -3 vertical, 0 horizontal. Okay, now here's my equation. So remember that we did a cancel. So what does your equation look like after you've canceled that? What would you write? How would you simplify it with that and that gone? Did you do that? 1 over x plus 3? Okay, so now we are going to try to graph it. Okay, so what I usually do is I look at my vertical asymptote and I take 2 on this side and 2 on that side until I see a pattern. So if I insert a -2, so I'm going to do that one. So if I insert -2 into this, what is 1 over -2 plus 3? That's what I'm doing in my head. So -2 plus 3 is 1. 1 over 1 is 1. I'm going to do a -1. So 1 over -1 plus 3 makes 1 over 2. Do you see what's going to happen, or do I need to keep going? We can go one more. 1 over 0 plus 3 is 1/3. Can you predict what the shape would be? Remember how we treat asymptotes? We go towards them, we can't touch them, we don't curl away from them. Okay, so now I'm going to pick 2 on this side. So I'm going to do a -4 and a -5. I'm going to pick those on that side. So 1 over -4 plus 3. I'm getting a -1. 1 over negative 5 plus 3 makes negative a half. But there's something important about this. What did we remember from the top? It's a whole. So here's what I need you to do. I need you to draw an open point there. Okay, so your hole kind of needs to look like that. Okay? Does that make sense? That's what I'm just going to do. I'm going to skip over that spot in the graph. Okay. Do we know how to think about domain and range on these questions? Okay, let's try to think about domain. What's the most left we go? So negative infinity. So pretend I'm traveling the road. Traveling, traveling, traveling. What's the first x value I hit where it's bad? Negative 5. And then I jump over it. I jump over the hole. So now I'm here. So negative 5, I'm going to continue again until I hit negative 3. And then I'm going to jump over it. And then I'm going to start again just after negative 3 and go on. Okay, do you think you could try the range on your own? How would you do a range thought on that? So thinking about traveling on road and like skipping over what? Skip over something. So negative infinity to what's the first height you hit where you'd really have to jump over that spot? Before 0. Negative a half, because it's the hole. So I have to jump over that hole. And then negative a half, then I hit the 0 line. Okay, so you always are jumping over holes and asymptotes. Oh, bless you. Okay, let's do, I'm trying to see if we can do 2 more here. NPV, what's the not allowed value for the bottom of this graph? Negative 1. Would anything on the top cancel that? Can you think of it like this really would be that, but there's no canceling, right? So it is a vertical asymptote. Okay, some questions might just say like, what is the equation of the asymptotes? So make sure you do an x equals on that one. And what do we know about the degrees? What are you doing with the degrees? Are they the same or higher somewhere? Higher on the top. So what's the rule when they're higher on the top? The numbers will just get bigger because the top number gets bigger. Okay, so what x values would you pick to fill in? I would probably do 0 and 1 and hope I can see a pattern. So I'm going to pick 0 and 1. So 0 squared minus 4 over 0 plus 1 makes negative 4, right? Okay, 1 squared minus 4 over 1 plus 1 makes negative 3 over 2. kind of feel like I want to do one more now. Okay, so I'm going to do 2. 2 squared minus 4 over 2 plus 1. Oh, that makes 0 because the top is 0, right? Okay, so remember that there was no horizontal restrictions. So do you see my arrow is going to show you just going up forever, down forever? Okay, are you okay to do this quicker? I think if I plug that in, I should get 0, right? And then on this one, I'm going to get negative 2.5. And on that one, I got negative 4. Okay, one more today. I had a few more but we'll do some recappers tomorrow. Okay, last one. No, Monday. That's right. Okay, what's not allowed? 1, is it an asymptote or is it going to be a hole in the graph? It's going to be a asymptote. There's nothing that canceled it. Vertical asymptote at 1. Okay, tell me what's going on with the degrees. That's what we're asking ourselves next. The degree is the same. So that means I'm going to have an asymptote y equals, and what's the division of the boss? Y equals 5, right? So 1, 2, 3, 4, 5. Okay, so now here's what I'm going to do, so you can get working faster. I'm going to pick 2, right? We're going to plug in a 2. So here we go. 2 is a 10. 2 comma 10. I'm going to plug in a 3. So 3 is 7.5. So when I plugged a 2, I was at 10, 3 is 7.5. Do you have the shape good to go? You see what's happening? It's going to just go lower to 5, right? Okay, I'm going to flip to the other side of the asymptote here, so I'm going to use the x value 0. So 0 is 0. And then I'm going to use a negative 1, which is 2.5. that give you enough of the shape there? So down that way and then to the left. Okay? And sorry, applied people, you cannot use your calculator.